Right. So the various options that we are considering is, hey, how about I just have a picture of the orange, or have a picture of Mars or the Earth, or anything that we might want to wrap around, right, and then just paste it on that geometric model, right, where we might start with a sphere for our planet, for our fruit, right, and then just wrap our geometry with this image and with this picture. And so that technique is what we refer to as texture mapping, right, where as we consider all the various triangles and all the various points on the surface of those triangles, we need to say, okay, well, which pixel from my source picture, right, am I going to use to render on top of that surface? So we need to create a function that iterates usually in our fragment shader, right, as it interpolates over the vertices of our surfaces, and it considers every single point on the surface. Our rasterizer, as it generates all these points, we have to be able to go back to our original picture and say, okay, which pixel from the image should I render? They will give us a color, the RGB color, should I render to on that point. Now, it might be that just the picture might not be enough, right? We need to also, if we just do that, right, and wrap an image of Mars on top of the on this sphere. From far away, it might look wonderful, right? But as you get closer and closer and closer, things that seem to be ridges and dimples and valleys and whatnot, it turns out that even the closer you get, you notice that indeed it's just very smooth, right? The surface is very smooth. It is flat, actually, right? You see some of this in some images from Google Maps, more with Apple Maps, right? Where at the beginning you would see that a lot of these surfaces, although when you saw it from far enough, right, they look 3D, but the closer you got, you saw that it was just pasted on top of a flat surface. Now, bump mapping allows us to add some additional realism, where not only do we have information about which pixel are we rendering on top of each point on a 3D geometry, but we also have information about the normals, and that would let us would if the normals change for a particular point, right? Not only we have color information, but we have normal information that can add to our realism by using that normal information and calculating what the light would be, what the light effect would be on that point, right? And it would tell us, well, this is should be brighter or should be darker depending on how the light is hitting it, and that certainly could add additional realism to the geometry.